See, I have got a very good question, numerical problem on physics. What it's saying is a small body of mass m slides without friction from the top of a hemisphere of radius r as shown in the figure. What at what height will the body be detached from the surface of the hemisphere? Now see, there can be a situation where the radius of the hemisphere will be given and they will ask for finding a specific height from which the body will get detached. In that case, the radius of the hemisphere, that is r or r, should be given. Say for example, that is the radius of the hemisphere is 5 meter, and for determine the specific height, in that case we will need the mass of the body. Suppose the mass of the body m is say for example 2 kg, and we need the height, we need to determine the height from which the body will get detached. So in that case we need to draw a hemisphere. Now suppose this is our hemisphere, this is our hemisphere. See, this one is our hemisphere. Now suppose O be the center of the hemisphere and A be its topmost point. Okay, now suppose at any instant the object is at the point B, moving downward through the hemisphere with a velocity v. So at point B, the forces acting on the object, therefore the forces acting on the object at point B will be, the first one will be its weight, that is weight of the object, that is mg, which will act in vertically downward direction, that is mg. And the second one is normal reaction due to the hemisphere, that is n. So normal reaction will act vertically in outward direction, so this one is n. Now in this case the component of the weight, that is if this is theta, then this component of the weight mg cos theta will act always toward the center. Now in this case, suppose c, that is AC, that is x, be the vertical displacement the object has gone through. So the working equation of the object at point B will be mg into cos theta minus n. Now n is minus because mg cos theta is acting vertically, acting in inward direction, and n is in the opposite direction. So mg cos theta minus n, and both of them are necessary to provide this centripetal force mv square by r. Now as the object moves through this hemisphere, the normal reactions v will increase and normal reaction n will decrease. As a result, there will be a situation when mg cos theta will be equal to mv square by r, that is n will be equal to 0, and this is the point of the detachment. Now here comes the judgment of the physical situation. See, both of this mg cos theta and mv square r both are acting in inward direction, and the only force that is acting outward direction, that is away from the hemisphere, is n, which can be responsible for the detachment of the object. Still we are saying the object is getting detached from the hemisphere when n is getting 0. Now why this is so? Because see, this mv square by r, that is their centripetal force, there is no additional centripetal force. Both mg cos theta and n both are working to provide this necessary centripetal force, And there will be a situation when n equal to 0 and mg cos theta, that means weight is sufficient to provide this, weight of the object is sufficient to provide the centripetal force. And at that point, the arch of the body to rotate around a circular path is so high that it will try to rotate in a circular path, but it will not be able to do so, because in that case n is 0, because see, n plus n is equal to push, plus n can be treated as push, therefore minus n can be treated as pull, therefore any value of n below 0 can be treated as pull. Now there cannot be any situation where the hemisphere is pulling the object, therefore negative n is not possible. So mg cos theta is equal to mv square by r is the only situation. That means v square is equal to g into r into cos theta. Okay, now after that we can solve this problem in two ways by employing, first one, suppose first method, energy equation by energy equation, that is energy at point A of the object is E, say it is E is equal to kinetic energy plus potential energy, but there is no motion of the object, therefore all of its energy is potential energy, and that is mg into r, or mg into capital R. Now at point B, energy, total energy of the object is equal to kinetic energy, that is half m into v square, plus potential energy, that is potential energy is mg into r cos theta. So it will be half into m into mg into r cos theta plus mg into r cos theta. So this one will be equal to total energy mgr. Now if we cancel this mgr, we can write 1 is equal to half into cos theta plus cos theta, so it will be 3 by 2 cos theta, so cos theta will be 2 by 3. Now we can determine this cos theta can be derived by alternate method, say alternate method, see the height the vertical drop the object has gone through is AC, that is x, its initial velocity u is equal to 0. So if we apply the equation of the kinetics, that means v square minus u square is equal to 2 into a into x. So we can write v square is equal to 2 into g into x. So v is equal to under root of 2gx. Similarly, from the triangle OCB, we can write cos theta is equal to b by h. So b is this one is, see, this one is theta, so this one is b, so OC, that means this height which we have to determine is h, is it's b, so h by r, because this hypotenuse is equal to radius, so h by r. Now we can substitute this equation into mv square by r is equal to m into g into cos theta. See, therefore we can write m into, in case of v square, we can write under root of 2 into g into x whole square divided by r is equal to mg into cos theta is equal to h by r. So this r will be cancelled out, m will be cancelled out. Ultimately, we will get h is equal to 2x. Since x is equal to r minus h, see, you can see here that x is equal to total radius. This one is total radius, so this one is r, so r minus h, so we can write x is equal to r minus h. Therefore h is equal to 2 into r minus h. Substituting the value of x, we can write h is equal to 2 by 3 r. So now we can determine height from the ground. From where it will get detached, it will be h is equal to 2 by 3 r, or 5 into 2 by 3, that means it will be 3.33 meter, and speed at the separation will be v square into is equal to v square is equal to gr. See, v square is equal to gr cos theta. V square is equal to gr cos theta. So this one will be g into r into cos theta. So g is equal to 9.8, r is equal to 5 into cos theta is equal to 2 by 3. So we can write 32.67. That means v is equal to 5.7 meter per second. So we can say the body, ultimately we can say the body will detached when h is nearly equal to 3.33 meter, theta equal to, that means cos theta equal to 2 by 3, and speed equal to 5.7 meter per second if radius r is equal to 5 meter and mass of the object is equal to 2 kg. Now this is a very good problem because we have seen that we have applied all the conservation of energy, circular motion, normal reaction concept, free body diagram, the concept of centrifugal force, and especially the judgment, the physical judgment when the body will get detached.